All right, welcome to another deep dive, everybody. Today we're taking a look at, well, quite a big one. Boiler operation and maintenance. A real classic. And actually, you listeners sent in some pretty extensive excerpts from this thing covering everything from like day one startup to how to properly store these huge machines when they're not in use.
Yeah, it's pretty comprehensive.
So our mission, if you will, for this deep dive is to, I guess, boil it down, to give you the real core knowledge, the crucial stuff you need to understand how to run these things, keep them running safely, and, get the most out of them. We want to help you squeeze every bit of efficiency out of your boiler.
Right. And this manual really hammers on this idea of being built to outperform. So really what we want to do is sort of pull out the core procedures, right?
Mhm.
And the thinking behind them, the stuff that makes all this high performance and reliability actually happen. So let's start, I guess, at the very beginning. Initial startup. Now, if the manhole covers haven't been messed with since the factory, you might not need a full internal inspection right away. But what comes next seems super important for getting things running the right way, right?
Oh, absolutely. That initial chemical treatment, it's a fundamental step. This manual is very specific. 20 pounds of trisodium phosphate, 2.5 pounds of caustic soda, and that's for every 8,000 pounds of water.
That's a lot of water.
It is, yeah, it is. And the thing is, this isn't just tossing in some random chemicals. This ratio, it's crucial. The trisodium phosphate that helps get rid of any hard salts in the water prevents that nasty scale buildup on the inside of the boiler. And the caustic soda, that bumps up the pH of the water, helps prevent corrosion. Big time.
So you're really setting things up for the long haul with that initial chemical balance.
Exactly. You got to get that right from the start. And this solution, you have to make sure it's all dissolved properly. Then you pour it into the boiler. Through the manhole, if it's open, or you can use the chemical feed system.
Makes sense. So we've got our chemicals in, but hold on. Before we even think about lighting this thing up, which sounds like the fun part, there's a whole bunch of pre-lighting checks, and these seem pretty serious. Like you can't skip them.
Oh, no, they're non-negotiable. It's all about safety, right? First, you double-check all the blow-off and drain valves, make sure they're installed right and you can operate them safely. Then, that safety valve discharge pipe, that's the one that releases excess pressure that needs enough room to expand upwards as the boiler heats up. You don't want that thing getting restricted.
And the water level indicators, those gauge glasses.
Oh, yeah, got to make sure those are working perfectly, showing accurate levels. And finally, the equipment you're using for burning fuel, temporary or permanent, that needs to be in top-notch, safe condition. Follow all those safety rules for the fuel you're using.
Okay, so we've got everything hooked up. Initial chemicals are in. Safety checks are done. Now we get to introduce some heat, but not before we purge the system. What's the thinking behind that?
Safety first, always. Got to make sure there's no combustible gas hanging out in there before you introduce any flame.
This manual is so clear on this point. Run that forced draft fan, the one that pushes air into the combustion chamber, for at least 5 minutes, at 1/4 the unit's max capacity.
Basically clearing the air, literally.
Exactly. And the important thing is, if the burner flame goes out during startup, you got to do that whole 5-minute purge again before you relight. No exceptions.
Okay, 5 minutes, got it. So the burner's lit, we're going at the minimum rate. Now, how do we bring that pressure up?
So we start by venting, leave the drum vent open, usually it's at the top of the boiler, and you keep it open until steam blows out steady at around 5 sig.
Pounds per square inch gauge. That's just how we measure pressure. Anyway, this venting, it gets rid of any leftover air inside the boiler, which can mess with your heat transfer and even cause corrosion over time. Once that steam's flowing steady, you close the vent and keep firing until you hit 30 sig.
All right, 30.
Then, a very important step. You shut the burner off for 15 minutes. Let the temperature even out. This prevents too much stress on the metal.
A pause for temperature harmony.
Exactly.
Yeah.
After that, you fire it back up, still at that minimum rate, and aim for 75% of the normal operating pressure, or 100 sig, whichever is higher. This might take an hour or so, and during this time, you want to periodically blow down the water column and the gauge glass. Clear out any sediment, any stagnant water in those lines. You want to make sure you're getting good reading on that water level and everything's warming up evenly.
Makes sense.
Also, quickly open those continuous and lower drum blowdown lines too. You got to flush out the junk.
All right, we've hit that 75% 100 sig mark. What next?
Another holding period. Keep the burner cycling to hold that pressure for about 4 hours. And keep those continuous blowdown lines cracked open just a little bit. But you don't want those safety valves popping off during this phase. The water's still got a high concentration of those initial chemicals, and that can mess up the safety valves.
Don't want that.
No, not at all. No, during these 4 hours, every hour, you're going to do a cyclical blowdown, fill the boiler up to 3/4 on the gauge glass, then blow it down to 1/4. Just keep doing that every hour.
Up and down, up and down.
Exactly. Oh, and don't forget to blow down the gauge glass itself, the water column, and those continuous blowdown lines. Just a quick blast each time.
So we've held it for 4 hours. We're getting close to actually using this thing. What are the 100 steps to go live, I guess?
All right, so fill the water level almost to the top of the gauge glass. Keep firing to hold that 75 to 100 sig range. Then do another blowdown, bringing the water level down to about halfway. This is to get those initial chemical concentrations down to normal operating levels. After that, you bring the water level back up to normal, and then you can finally start raising the pressure to the full operating level.
The moment of truth.
Once you're at operating pressure, you set those safety valves to the pressure that's stamped on their nameplates. And then you're ready to go live. Open that main steam valve and let the steam flow into your system.
But hold on, we don't just slam the gas pedal to the floor.
Oh, no. You want to ease into it. Start with no more than half the intended load. After 4 hours at half load, or 12 hours if you can't hit half load right away, you do another blowdown. This is to double check that the water concentration is where it needs to be.
Checking the levels again. Okay, so anything else to watch out for during this initial run?
One more thing. Check that gauge glass. Look for any oil floating on the water. If you see any, that means you've got contamination somewhere. Keep blowing down those lines. Gauge glass, water column, feed water regulator, continuous blowdown until that water is crystal clear. Oh, and if your boiler has a superheater, there are some extra precautions for those.
We'll have to dig into those another time.
Definitely.
So that was the initial startup. What about a normal startup after the boiler's been shut down and cooled off? Is that a whole different animal?
It's actually a lot more straightforward. Close the main boiler stop valve, open the drum vent, and get that water level just a bit below normal. Then you light the burner, again starting at the minimum firing rate. And if you've got a superheater, you'll need to watch those thermocouple readings to make sure you don't overheat it before there's enough steam flow.
So even in a normal startup, we're still venting that air out first.
Yep, got to get rid of that air. Keep the drum vent open until you see a steady flow of steam coming out, about 5 sig. Close it up and keep firing until you hit 30 sig. Then, same as before, 15-minute shutoff to let those temperatures even out.
That temperature equalization seems super important.
It is. Prevents all sorts of problems. Then you relight, keep firing at that minimum rate, and bring it up to your normal operating pressure. That's usually 45 minutes to an hour. Once you're there, you switch the water level regulator to automatic, start the feed water pump, and finally open that main boiler stop valve. As the demand for steam picks up, you adjust the air and fuel to keep the pressure right where it needs to be.
So we've got our boiler humming along. Now let's talk about something that seems really crucial for its long-term health: water treatment. This manual talks about 3 major problems that come from not doing that right. What are we trying to avoid here?
The manual really lays it out. First problem, internal deposits. We're talking scale, sludge, that sort of thing. They act like insulation, blocking the heat from getting to the water. That can cause overheating, tube failures, all sorts of trouble.
And that's from minerals in the water.
Exactly. Calcium, magnesium, stuff like that. Best way to prevent it is to treat the makeup water. The water you add to the boiler. You can use softeners, demineralizers, evaporators, lots of options.
So lots of ways to keep things clean inside. What's problem number 2?
Internal corrosion. That's when the metal itself starts getting eaten away, usually caused by dissolved oxygen in the feed water. That oxygen loves to attack metal, causes pitting.
Pitting sounds bad.
It is. You can prevent it by making sure that feed water is properly decarriated, meaning you're removing that oxygen before it gets to the boiler. You can also add chemicals to the boiler water to get rid of any remaining oxygen. And keeping the pH right, that's huge for preventing all kinds of corrosion.
So we're keeping things clean. We're keeping things from corroding. What's the third issue?
Carryover. That's when impurities or even droplets of the boiler water itself get carried out with the steam. This can plug up your steam lines, damage machinery down the line, even contaminate your product if you're using the steam for something like that.
And what causes carryover?
Usually it's foaming in the boiler water. Too many solids, leaks in the drum baffles, or the water level being too high. To prevent it, you got to keep those solid concentrations within limits, make sure your drum baffles are tight, and make sure your feed water regulator is working right.
It really sounds like water treatment is a whole science in itself.
It really is. This
But
manual even recommends getting professional help. They say it's better to work with a company that specializes in water treatment rather than relying on the boiler manufacturer for advice. They really know their stuff.
makes sense. So what are we aiming for with the water itself? What are the ideal conditions, both for the water going in and the water inside the boiler?
All right, for feed water, you want zero dissolved oxygen. Absolute max is 0.007 ppm. pH should be at least 7. Slightly alkaline is better. Hardness, that calcium and magnesium, ideally 0 for temporary hardness. Max 17 ppm is calcium carbonate. Total dissolved solids, keep them as low as possible. No suspended solids, and absolutely no oil or organic matter.
Wow, that's some seriously pure water.
Yeah, the cleaner the better. Now, for the water that's already in the boiler, alkalinity should be between 100 and 250 ppm as sodium carbonate. If you've still got some hardness, keep that sodium phosphate level between 30 and 60 ppm as disodium phosphate. Chloride should be under 500 ppm as chlorine. The lower, the better. pH at least 10.8, ideally between 11 and 11.5, and again, no oil or organic matter. Total dissolved solids, that depends on your operating pressure. Up to 300 C, the limit is 3,500 ppm. 301 to 450, 3,000. 451 to 600, 2,500. And 601 to 750, only 2,000 ppm. Silica, another thing to watch out for, also depends on pressure. Below 600 sig, 50 ppm max. 600 to 750, 25 ppm. And never more than 1% of the total dissolved solids.
Lots of numbers to keep track of.
It is a bit of a balancing act.
Okay, so beyond the water treatment, what about day-to-day checks? What does the manual say about that?
So daily, you want to blow down that gauge glass, just a quick blast to clear out any sediment and make sure you're getting a true reading. Then test the boiler water concentration, see if it's within those limits we just talked about. And finally, check that low water cutout. You can do that by intentionally lowering the water level to see if the system shuts down the burner like it's supposed to.
Safety first. Now let's talk about shutting this thing down. The manual talks about both normal and emergency shutdowns. Let's start with the normal ones.
Okay, so for a normal shutdown, when the demand for steam drops below what the last burner can handle, you close the fuel and control valves to that burner. And if you've got a separate oil pumping and heating system, shut that down properly too.
What about the water side?
Once that non-return steam valve closes that prevents steam from flowing back into the boiler and you don't need feed water anymore, you stop the feed water pump and close the isolation valves on the feed water regulator. Especially important if you've got multiple boilers running off the same pump. Let the pressure drop naturally as the boiler cools down. Keep all those blowdown valves and the steam vent valve closed for now. If you've got multiple boilers on a common header and you're shutting one down for a while, manually close that non-return valve, just to be extra safe.
So everything's shut down. What about actually cooling the boiler down?
Okay, once the brickwork inside the furnace is cooled down enough that it's not glowing anymore, you can open the dampers to help things cool off a bit faster. But don't run the fan, that can cool it too fast and cause stress.
Right.
When the pressure gets down to about 25 psi, open the steam drum vent valve. That's to stop a vacuum from forming as the steam condenses. And if you got a superheater, open its drain valves too. And don't drain the boiler completely until the furnace is cool enough to go inside.
Okay, that's a normal shutdown. But what about those uh-oh moments? The manual mentions low water and tube failures. Let's start with low water. That sounds scary.
It is, and the manual is very clear. If that water level drops below the sight glass, shut off all fuel immediately. No ifs, ands, or buts. And if the water stays out of sight, do not add water until the boiler has cooled down to within 100 degrees Fahrenheit of the incoming water temperature. You can cause a huge, dangerous pressure spike if you add cold water to a hot boiler.
So low water, shut it down. What about a tube failure?
If the tube failure causes a low water situation, follow the low water procedure. If it causes the burner to go out, shut off the fuel and cool the boiler down normally. But if you can maintain water level and the burner stays lit, you might be able to keep running until you can shut down properly. But watch out for external corrosion from leaks. That can cause more problems.
So the boiler's shut down, one way or another. Now comes the part where we keep it in shape. Inspection and cleaning. The manual says you have to do this regularly.
Absolutely. They recommend a full inspection after the first month or two of operation. That way you get an idea how often you need to do it. And depending on how clean things are, you can extend the time between inspections. But always keep safety and efficiency in mind.
So before we even think about sending someone inside the boiler, there are some pretty serious safety steps, right?
This is where it gets really important. First, lock out those fan motors. Tag them out so nobody accidentally turns them on while someone's inside. Then, make absolutely sure no steam or hot water can get into the boiler from any other connected unit. Lock and tag those valves closed. Same goes for all the main steam and feed water valves. If you're using temporary electrical lines inside, make sure they're safe, properly grounded. And everyone needs to know when someone's in the boiler. No exceptions.
Okay, it's safe to go inside. What are we looking for in the steam drum?
First, corrosion. Any thinning of the metal, pitting, anything like that. Look for deposits, scale, sludge. Any oil means you probably got contamination in your feed water. Overheating can show up as the drum being out of round, sagging, discolored. And finally, check those welds for any cracks.
And it's not just the drum itself, right?
Nope. Check those internals too. Heavy sludge, leaks, loose baffles. Make sure those baffles are tight, no damage. Look for sludge in the pipes, everything nice and clean.
How about the tubes? What should we be looking at there?
Same as the drum, looking for corrosion, deposits oil. If the tubes are overheating, they might be bowed, swollen, cracked, maybe even ruptured if it's bad enough. Check the tube seats too, where they connect to the drums. Look for leaks, any signs of trouble.
So if you find deposits, how do you get rid of them?
Depends how bad it is. Sometimes you can just wash them out with high-pressure water. For tougher scale, you might need to use a turbine. That's a tool that spins inside the tubes and scrapes the scale off. And for the really bad stuff, you might need to use acid. But that's a last resort, and you always want to get expert advice before you go that route.
So internal inspection is done. What about the outside of the boiler?
You want to check for overheating on the tubes and drums, look for leaks, corrosion, make sure the fuel burning equipment is working right, no wear and tear. Look at the setting, the casing, and refractory lining. If you see hot spots, that means the refractory might need repair, especially around the burner.
Anything else?
Oh yeah, check the doors, make sure they seal properly. Look at the refractory liners and gaskets, the ash ducts, make sure there are no blockages. Fan blades and dampers, nice and clean, no restrictions on airflow. Drain lines from the water column and gauge glass. Check for clogs. Look at all the valves for leaks. Make sure they're packed properly. And finally, give those instruments and controls a once-over. Clean them, make sure they're working, recalibrate if you need to.
You really have to check everything.
You do. It's all about being thorough.
And what about the heating surfaces themselves?
You can clean those externally. Brushing, scraping, blowing them out with air, washing them down. Just be careful with the refractory. You don't want to damage that.
So we've covered running it, stopping it, keeping it clean. What about when it's time to put it away for a while? What's the deal with boiler storage?
So the manual's really big on being careful and doing your prep work when you're storing a boiler. There are two main ways to protect the inside. Dry storage, best for longer periods, and wet storage, if you might need to use it again soon.
What's involved with dry storage?
First, you drain all the water and clean it thoroughly, inside and out. Get rid of all the ash, soot, anything that could hold moisture. Then, you seal up all the openings, airtight. You can put some moisture-absorbing material inside, like lime or silica gel, but don't fill the trays all the way. And you absolutely have to make sure there are no leaks. Check it regularly for any signs of corrosion and top off that moisture absorber.
And wet storage. When would you do that?
If you think you'll need the boiler again pretty soon, wet storage might be better. You start by steaming it for a bit, get the water stable and push out any oxygen. Then you cool it down slowly and fill it almost to the top with treated water. Add some sodium sulfite. That helps prevent corrosion. When the pressure is almost gone, open the vent and fill it completely with water, then close the vent. Leave the drain open on the boiler side of the main stop valve. Keep filling until you hit 10 psi against the non-return valve. Watch for any pressure increases, that could be a leaky valve, and check for water loss. You can check the water level by adding more water until it comes out the vent.
So, lots to think about with internal storage. What about the outside?
Clean off all that ash and soot. Close up the setting and keep it closed. Check it regularly, especially if you're doing wet storage. Look for any condensation, any rust starting to form. If it's humid, you might want to use some heaters to keep the metal above the dew point. That'll help prevent condensation.
The manual even goes into detail about rigging and offloading, even though that's usually the customer's responsibility.
Yeah, and they're really big on safety. This is just general information. You have to follow all the safety rules on the job site. Only qualified people should be rigging and moving the boiler. And they make it clear, if you mess up and damage the boiler or someone gets hurt, it's on you, not them.
Makes sense.
These DS-type boilers have these steel base beams with angled ends for jacking, and they have lifting lugs on the drum ends. They tell you how to rig it using those lugs with shackles and straps. They specifically say no chains. Those can damage the casing. And you have to use the right size straps and shackles for the weight of the boiler. That info is usually on the drawings, and you should check with the shipping company too. And they recommend using 3 cranes, 2 in the front and 1 in the back.
So if we're storing the boiler for a really long time, like years, what then?
That's long-term storage. The manual has a whole section on that. Ideally, you want to keep it indoors, control temperature, all that.
Right.
When you can't, they have a procedure. The customer's responsible for making sure it's done right and keeping an eye on the boiler. And they're very clear that the warranty starts when the boiler ships, so any damage during storage is on you. They really stress documenting everything. Take pictures before you store it. Write a report if you see anything unusual. Keep a logbook, just in case.
So how do you actually protect it for that long?
For the tubes, they recommend a nitrogen blanket. Basically, you drain everything, seal up all the openings really well, then you try to get rid of as much remaining water as possible. You can heat it a little, maybe use a vacuum. Then you fill it with nitrogen gas, pure nitrogen, and keep a slight positive pressure. Check the pressure every week. Write it down.
So you're basically replacing the air inside with nitrogen.
Exactly. No oxygen, no corrosion. Then for the furnace, you seal up all the openings there too. Tape over the burner, seal the gas outlet, close the dampers, put some desiccant trays inside to absorb any moisture, like silica gel, and check it every 2 weeks, replace the desiccant. Outside, wrap up any loose trim, cover the whole thing with tarps, and if you have power, you could put a heater inside just to keep it above freezing. They also say to keep any loose parts that came with the boiler in a climate-controlled warehouse. And when you're taking it out of storage, remove everything carefully, document everything again, and if there's any damage, you got to get the manufacturer to check it out before you start it up.
There's a ton of documentation for these things. Pre-startup checklists, data sheets, it's a lot.
Yeah, Superior Boiler doesn't mess around. Before they'll even come out to start up the boiler for the first time, you have to fill out this huge pre-startup installation and system readiness checklist. It covers everything: the boiler, the auxiliary equipment, the feed water system, the fuel system, steam piping, safety valves, blow-down piping, chemical treatment, steam vent piping, electrical systems, you name it. You got to make sure everything's installed right, working right, tested, and safe.
Sounds exhaustive.
It is. And then there are all these tests they do. Operational tests, efficiency tests, performance tests. They check the safety limits, the controls, the emissions. They have data sheets for everything.
And ASME data papers, what are those all about?
Those are the official documents, like the boiler's birth certificate. They prove that the boiler was designed and built according to ASME code. It's all about safety and making sure the boiler is legal to operate. They even have a whole section on the warranty.
Oh, right. What's the deal with that?
It covers defects in design, materials, workmanship for 1 year after the boiler is first fired up, or 18 months from the shipping date, whichever comes first. But you have to operate it properly and let them know right away if there's a problem. And they don't cover problems caused by bad water treatment. That's on you.
What about spare parts?
They have a list of recommended spare parts, gaskets, valves, gauges, things like that. It's a good idea to have these on hand, just in case. It can save you a lot of downtime if something breaks.
And finally, there are the valve and instrument lists.
Right. They list out every valve and instrument on the boiler, tell you who made them, what they do, their specs, and they include the installation and maintenance manuals for all that stuff.
It really is amazing how much goes into these things.
It is. It's like a whole ecosystem.
Well, I think we've really gone deep on this one. We've covered everything from startup to shutdown, water treatment to storage, even rigging and documentation. It's clear that operating a boiler safely and efficiently is a real science.
It is. And this manual, it's really a testament to that. All the detail, all the procedures, it all comes back to that idea of building to outperform. It's about doing things the right way every step of the way.
And, thinking about all these tiny details, all these checks and balances, it makes you wonder how much of the world around us, the things we take for granted, relies on this kind of hidden complexity. It's fascinating to think about. What other incredible systems are out there working silently behind the scenes, keeping everything running? That's something to ponder.
It is.
Until next time.